Welcome to the shop. Well, the glasswork is finished and 4 successful hexagons were produced. Unfortunately, since they were made by hand, they're not all precisely the same size and they're not all precisely hexagonal shape, even though I did kind of, in the process of fusing them, I did put them in the squeezer and kind of touched them a little. By the time they got finally put together with all the paddling that I did, they're not the same shape, they're not perfect, the corners aren't square, and they look fine, they look perfectly nice. So I tried to figure out, okay, now what am I going to do? And well, I'm going to make a sculpture. And the sculpture is going to involve wood and metal. Today I'm going to be making the metal part. And to kind of camouflage the unevenness of the glass, I'm going to inlay the glass into some darkish wood, and hopefully the unevenness and the irregularity won't just jump right out and scream, hey, I'm wrong. So today, I'm going to be using the mini mill for prototyping for the first time, because I usually do my prototyping on the Bridgeport, and then because one-off things just tend to be faster and easier to just whip out on a 2-axis CNC. But today, because the thing I'm making is slightly complex and I need the practice, I'm going to go ahead for the very first time on camera and attempt to make the aluminum frame, which is going to get wood inlays, and then the wood inlays are going to get wood inlays and glass inlays. So it's going to be a multi-step inlay procedure. And to start off with, over here at the mini mill, I've removed the vices and I put an aluminum tooling plate on the table. I didn't indicate it or anything, I just kind of put it where it fits, and it's held down with some screws, and it has a 1/2-inch spacer to keep the aluminum plate off the table, because I'm going to be drilling and tapping some holes, and I certainly don't want to have any chance of hitting my table. So I've got my blank here, cut to size on the table saw. Probably not necessary to show cutting a blank to size on the table saw, but for those who are interested, with a proper aluminum cutting blade, don't be using a wood blade now, with a proper aluminum cutting blade, sharp, and some WD-40, aluminum cuts like perfect, like almost machine shop tolerance on the table saw. So I put my blank in place. This tooling plate has a whole bunch of holes in it. It's got 5/16 holes on a regular grid. And yes, I did make sure that the holes I'm going to be drilling don't intersect the holes that I've already got in the plate. And if they did, I'd have to move my blank a little bit. So I've got the blank attached down with some little kind of hold down guys. And it's nice and rigid. So now I'm going to use the Renishaw probing macros to find the 0 point, which is here. And once again, I don't care about indicating it in this dimension because close enough is good enough. It's in there by eye. The plate is oversized compared to what the final thing will be. The outside will be machined away to produce the final size on this tooling plate without moving this tooling plate. So I'm going to get a good part, even though the tooling plate and the blank were both put in rudely, crudely, approximately by eye. Close enough is good enough. So I'm going to jog over here, and as usual, I'm in the wrong mode. Oh, I hate modal software. So just kind of, the Renishaw probing macros when they don't have any idea at all where to probe from, you gotta kind of like eyeball adjust, kind of sort of roughly. And the nice thing about the Renishaw probing macros, that they have what's called a protected move built in. And so if you make a mistake and configure the macro wrong, or probe the wrong edge or whatever, and the probe moves and hits a surface that it doesn't expect, it doesn't continue moving and destroy the probe. It stops with an error message and lets you correct your misconfiguration. So now I have it configured to measure this corner, and let me jog up a little bit. Okay, so while I'm talking, I kind of forgot where I was in the sequence, so let me get a reference here to measure with. The probe starts off the surface, moves outside of the outer corner, moves down, and then moves into probe. And so I have to get a pretty good idea where it is. So if I'm going to be moving down, let me get a spacer here. So I'm going to be moving down 1 inch. I used a spacer and a 1, 2, 3 block there. I'm going to be moving down 1 inch to do the probing. To try to keep things under control in the shop, and to try to make my tool paths so that I can reuse routines in between setups and not have to do a setup from scratch every time, I've created quite a lot of different work offsets. And when the vices are in place, I have 6 or 7 different work offsets for left side of the left vise, right side of the left vise. You can imagine all the rest of the combinations. In this case, I'm using work offset 14, which is one of those extra ones that Haas gives you that's beyond the normal G-code standard. And so it happens to be G154P8 is the work offset for tooling plate directly on table, no vices used. And as usual with anything I do on this, kind of like they say about carpentry, measure twice, cut once. So I'm going to go over here and look at the screen where it says work. I'm using the VPS templates that are provided by Haas for the mini mill, and the VPS templates configure the Renishaw probing macros, and they have nice little comments here that helps you make helps you from no, let's try that again, that helps prevent you from making stupid mistakes. So I'm looking here, outer corner, work offset G154.8. I'm looking at my work offset cheat sheet. Work offset 14, G154, P8, special for plate on table, no vices. Corner 4. Back left. 154.8, 0.3 minus 1. I believe I am correct. Going to have my finger on the stop button while I push the go button. And there we have it, completed successfully. So, next thing I'm going to do is go back over here to the VPS templates, single surface, 154.8 for the work offset. I'm going to be probing Z -1, which of course gives me another opportunity to complain. And hey, boy do I ever like to complain. You should hear me complain about my own work. I entered -1 for the Z travel looking for a surface, and it failed with an error saying decimal required. It requires 1 point and not 1. I can't imagine what software does that. That's insane. So let's get into position here. I'm going to be probing the 0 is going to be on the top of my part. Usually when I'm using my vices, my soft jaws with a ledge, I use the bottom of the ledge as the 0 point, and that way it doesn't depend on material thickness. If I'm trying to hold a thickness, referencing on the bottom of the part is a good thing so that I can skin the top and get a consistent thickness. In this case, what I'm looking for is I want the depth of cut to be correct, and I don't care how thick the piece is. Who cares? So it's a sculpture, it's art, who cares? So anyway, I'm choosing the top of the part to be 0, and I'm looking here to single surface probe, work offset 154.8, 154.8, probe direction Z -1, looks entirely reasonable. In the right mode, finger on the stop button, start deprobing cycle, and there we go. So now, always really careful. I mean really careful when I'm hand jogging with that probe in the machine, because it's an expensive probe, and breaking it, even though it does have a sacrificial end, I sure don't want to break my probe. So because jog mode can be so maddening and so frustrating about wrong mode, wrong button, I pressed the button but it didn't register. I pressed it again, okay, now it registered. I gotta be super careful and don't just like crank the jog wheel with the probe, or actually crank the jog wheel rapidly anytime until I see which direction it's moving. So, okay, list programs over here, frame inside, and first thing I'm going to be doing is a 1/4 inch drill. And normally when I'm in production, I've got the tool carousel is preloaded with all the tools that are necessary to accomplish the work being done. In this case, I just put in an option stop, and actually, can I even do that? This stupid thing might not let me do it. Having said all of that, I bet I can't option stop and load a tool. Let me find out. It may actually be for some odd reason preventing me from doing that. So let's find out, shall we? Okay, I can open the door. And look at that. Can't load a tool with a program. Wrong mode. Not available while running. So thanks a lot, Haas. You really screwed me on that one. Oh. So, boy, this is annoying. There's absolutely no reason they should do it this way. Absolutely none whatsoever. Okay, I edited out all of that tool insertion, so you know, on the Tormach, no problem. You can change tools by hand, you can change tools automatically, you can mix automatic and hand, it doesn't care. This thing, yeah, I don't know, I have no idea why they do what they do, but, so I'm going to try again, and got the option stop in place, 25% rapid. Because I'm using a fancy assignment scheme to assign tool offsets to the tool carousel tool number, and you know, you want to hear me rant about that, well, I'll go back to the other videos. It's important to make sure that I have the correct tool loaded, the correct offset loaded. So I've got a label on each one of the tools put on with a Dymo label maker. So I've got tool 31. I look here at the code where I see the tool offset 31 is correct. I've got offset 31 in tool 12. Looks like all is ready to go. I'm going to put it into single step mode now and select distance to go, and okay, that's looking entirely reasonable. That's not looking reasonable. I configured, I had the little valve there. I was washing down the machine before I got to work. And so I had the valve set for the manual coolant squirter. So let's, and I don't have to return the Z to the top, and I don't have to reset. I could have just restarted the program from where it was, but hey, I'm going to be careful. Option stop. Single block, stopping in a reasonable place, coolant on, looking at distance to go looks sane. These holes will eventually be the hold down holes when I take the clamps off and mill the outside profile. So, single block off. Do my tool change with 100% rapid. Now, checking here, tool 4, offset 4, which happens to equal tool 4. Sometimes it actually lines up that way. When I'm doing my production work, obviously time is money, and I don't like standing here watching the machine running slowly, and hey, I paid for a fast, powerful machine, so why not use the speed and power the machine has to offer? So for production, I optimize feeds and speeds and basically just try to get the job over with as soon as I can while doing a nice job and not breaking tools. For prototypes, I'm not going to go through and make 5 of these just to optimize fees and feeds. I'm going to go really, really conservative. Way more conservative than I ever would be in production. But hey, at least if I'm only looking for one part, I'm pretty much guaranteed to get one good part this way. So, non-aggressive feeds and speeds, option stop, single block, 25% rapid, looking sane, distance to go looks sane, sane, (10,000 RPM), 30 inches per minute, and yes, I know that I could probably do 120 inches per minute, but like I said, prototype, one-off, gonna be conservative. Yeah. I think I can bump it up a little in the control here. Bumped it up to 50. No problem. My philosophy for parts like this, I only need to make one part, and I don't want to ruin the part, I don't want to waste a blank, I don't want to break a cutter, I just want one part. So, conservative, slow, perfectly fine with me. And things appear to be going very nicely. Oh, looks like one of my coolant nozzles got bumped. It's hitting the collet nut. Doing a spiral ramp entry because, you know, it's easier on the tool. Yes, the thing will plunge cut, but a spiral entry reduces chip buildup on the outside of the tool, and it's just easier on the tool in general. Okay. Boy, that looked successful. Now, gonna be using the 1/4 inch 3-flute Lakeshore carbide. That last one was the 1/2 inch 3-flute Lakeshore carbide. Tool number 1, checking offset number 1. Going to be reducing the feed rate down because I know how easy it is to break one of these 1/4 inch guys. And so, you know, conservative, conservative, conservative. Single block. Going back to 25%. Looks reasonable. Looks reasonable. "30 inches per minute, 10,000 RPM. Conservative depth of cut. Got the finger on the stop button at all times. Cutting a slot here, and I seem to be having success doing it, not breaking my tool. I did clip the corner of that hold down, but hey, who cares? It's aluminum. Just barely clipped it. And like I said before, for newcomers to the wonderful world of CNC, finger on the stop button is good, but it's often not good enough. When things go wrong in CNC, they often go wrong so fast that even if your finger is on the stop button, you won't push it in time. Why I love simulation. That's why I love single step and all the other tools that are provided to make this process a little bit less terrifying. And yes, this machine can break itself really, really badly if you make a mistake. First time I ever pushed the start button, wow, that was an interesting day. And no, nothing bad happened. I had a successful day, but boy, talk about a bit nervous. Okay, it's definitely going to clip that other hold down, but good thing I used aluminum. Probably the biggest mistake that I usually make when I make mistakes, and no, I don't make a lot of mistakes, but when I make mistakes, my most common mistake is not being overly aggressive with feed and speed and breaking tools. My most common mistake is running the tool into the hold down screw. I don't, and I know it's possible in some cam systems, but I don't fully model everything, including all the hold downs and all the fixtures. I basically model the part as if it was just sitting magically in thin air. And Sometimes when I make a mistake, I run the tool bit right into the clamp. So, slow as can be. Don't want to break that little 1/4 inch mill, especially when cutting a slot. The good news and bad news about slot cutting. The good news is it's a balanced cut because the cutter is cutting equally on both sides. The bad news is chip evacuation can be a real problem. And often when I break cutters, it's really not because I'm exceeding the capability of the cutter, it's because I'm exceeding the capability of the chips to be evacuated. So, this is going to take a really long time. I might end up speeding it up, or not, I don't know. As with glasswork, when I face the same question, in glasswork it's very important to learn timing. It's one of the most important things that you learn as a beginner glassworker. In machining, you know, once the first pass has run, it may not be necessary to see the others, but I'll go ahead and leave the camera running and then decide during the edit if I'm going to leave it in. So, the actual visible part of metal in this sculpture is going to be almost nothing. When you look at the face of the sculpture, you're going to see wood and glass with a teeny weeny tiny little 60,000ths aluminum edge. Of course, the structure holding the thing together is going to be metal, and if you look at it from the back, you'll see aluminum, but the aluminum on this will not be the star of the show. Obviously, the star of the show is the glass, but the next in line as far as visually interesting elements should be the wood, and I think I've got the wood selected. It may be Paduke, it may be rosewood, it may be some other similar wood, but it'll definitely be a dark wood to show off the contrast with the glass and the bright aluminum, and I'll probably be showing that too. It may actually be interesting to see the process of doing multiple levels of inlay with metal, wood, and glass all inlaid into each other. So, just continuing to peck away at it, slowly and carefully. I clearly remember breaking so many 1/4 inch cutters. And actually, just for your information, I never wear out cutters, I just break them. Haven't worn out a cutter yet. Every one that I've thrown out has been broken. But in the process of learning machining, especially on the Bridgeport that only had the mist coolant, I broke so many cutters trying to go, well, let's see, can I bump up the feed a little bit? Oh yeah, looks like it's working. Can I bump it up another notch? Hey, looks like it's still working. Can I bump it up another notch? Boink! Oop, guess I can't bump it up another notch. Or what's even worse, okay, I just made 10 parts. Same setup, same cutter, same feed, same speed. 11th part breaks the cutter. So it must have been right on the hairy edge and just some little random piece of bad luck. Just boink. Of course, just when I say it's looking correct, well, that's the time it's going to have a problem. So, hey, gotta always be careful. And yeah, I know when I start talking, I take my finger off the stop button, so. And yeah, I probably could have done this in 2 passes, but once again, it's not just the cutter. And yeah, the cutters are expensive. They're solid carbide cutters, and I hate breaking them. But even more than that, usually when the cutter breaks, it ruins the parts. So I don't want to, it's a nice big chunk of aluminum, and I don't want to ruin that guy unless there's no way around it. So as long as the machine is working, talk a little bit about my artistic style. Many artists are known for a particular style. You hear about such and so artist, oh, that was their blue period, oh, this was his impressionistic period. Well, I think my style can best be characterized as 50s atomic age. And I don't know what it is about that stuff that just attracts me, but in the history of aircraft manufacture, aircraft of course started out as wood and wires and canvas, but when aluminum started being used for aircraft, they tried to make it as light as possible, so they cut a bunch of holes in it. And so the repeated pattern of geometric holes, often changing in size as they went along, is my current kind of signature art statement. And at least at the moment, everything I make got those holes. In this case, they won't be holes that go all the way through. They'll be holes inlaid with a different color wood. But hey, 50s atomic age. So, pretty darn boring, I tell you. I'm sure I could have done it 3 times the speed if I wanted to push it. But when you only have one prototype, or you only want to make one prototype, and you don't like wasting material and breaking cutters, slow is better. So, while the machine is working, for those who just like to hear me rant, if you don't like to hear me rant, well, you can just fast forward. But if you do like to hear me rant, here's a rant about music. Musical talent is not rare. Throughout all of human history, musicians have been common. In the days before recordings, pretty much every family had 1 or more members who could play. Musical talent is not rare. Every high school has 1, 2, 3, 4, 5 really good bands. Every college has good bands. There's thousands, there may be millions of good bands. And unfortunately, in the past, the record companies and the radio stations kind of created this myth. Oh no, talent is rare. There's only one star, and he records on my label. He or she, or they, or the group. They record on my label, and if you want the one star, you have to pay me whatever I charge. Well, you know, that's not true. But for such a long time, those of us who liked the non-mainstream music, I happen to like progressive rock and some of the other more experimental stuff. For those who liked the non-mainstream music, choices were limited. In the 70s, I had maybe 5 bands to listen to. Well, in the new modern world, things are different. About, I don't know, what, 6 months ago, 7 months ago, I discovered Spotify. Wow. Thousands of amazing bands. The recommendation robot is amazing. It reads my mind. It constantly picks new music for me. I listen to it and go, wow, I love that. My playlist is now probably 300 bands I had never heard of before, and they're all really good. and they're from all over the world. I just listened to a French band last night, and at first I thought they were German because the lyrics kind of sounded German, but then it turned out that, oh no, the leader of the band decided to invent his own language that sounds vaguely Germanic, and because he liked the sound of the way the words came out when sung. Oh, look at that. So anyway, the part looks beautiful. Exactly as planned. Wow, that's exactly what I wanted. So, next step, now don't get me wrong, I write music, I write lyrics, I like philosophical lyrics. Don't care much for love songs, but maybe that's just because there's so many of them. But, you know, I love lyrics. I'm a lyricist, I write lyrics. Actually, I write some pretty good lyrics. But I'd rather hear a foreign language or total made-up nonsense as opposed to stupid lyrics. Can't stand stupid lyrics. So I'm going to now tap these holes, and of course one of the downsides of doing this prototyping is that I kind of realized, you know, that really wasn't the smartest thing in the world. If I really cared about my precision and holding like the tightest tolerance I could, I would have tapped the holes first, because then I could put the screws in while the piece was clamped in place and not depend on the tolerance of the wigulation that's in the screws, but hopefully it won't be too big of a problem and I'll actually be able to produce a successful part. So now I've got to go back to the VPS template, or actually I've got to here's the problem, in case anybody's wondering why I'm fumbling and stumbling around here. I need to select the correct tool and the correct offset, and unfortunately the VPS templates don't generate G-code that selects the probe and the probe's offset. And so I need to go run one of my programs to select the probe and load its offset. But yeah, the VPS templates don't automatically load the probe. So now let me check here. Edit F4. Single surface probe 154.8 Z-1, checking tool 20, offset 20. If you don't get the offset right on the probe, you'll be in trouble. So now I've reset my 0 to the top of that plate, and handle jog Z, move real slow and careful before cranking the knob. Memory, list program. Okay, tool 33, tool 33, and that is correct. Single block, 25%. Does not appear correct. Why is that? Aha! Wrong work offset, G54. Off to the CAD room. So, check again. Just gotta be careful here. Looking much more sane. 154 P8. And that is lining up perfectly with the little dimple left by the last drill operation. Going to be tapping quarter 20 here. And it looks perfectly successful. Love that rigid tapping. So there, we have nice, happy little mounting holes, happy as can be. No good deburring tool. I'm gonna go get some screws. Make sure that the bottom surface is good. And there we go. I'm being so extra careful here to not drill into my table. I probably didn't configure the tap to go all the way through, but hey. No problem. Here we go. And yeah, sequence order again. I'm gonna Go back to the CAD room and modify something. What I was going to say, and once again, you know, this is the way prototyping goes. Sometimes in the middle of the project you go, oh yeah, that we really shouldn't have done it that way. I have the toolpath configured to use the top of the part as reference because I wanted my depth to be controlled. In this case, I want to probably use, since the tooling plate is already the zero reference and I don't want to like remeasure, and it makes more sense to ignore the material thickness and have the tooling plate be the reference. I'm going to go back and change the reference. I'm going to be using the Lakeshore Carbide aluminum shredder roughing cutter for the outside perimeter here. There's something funny going on there. And a mystery error. Probably made a mistake doing something, I don't know. Okay. So, part is securely locked in place. I'm going to list programs, frame outside, look at the time, 2:05, and yeah, 2:05, so it is the updated one that I just did. Option stop is on. That is tool 48, which is the roughing cutter. Now, when I was making parts on the Tormach, I would use this method, which is to cut the outside perimeter of a design, basically using slot cutting, and of course being careful about chip evacuation because slot cutting is sometimes a troublesome operation. And so I would do the outside of all of my parts with slot cutting. And then when I got the mini mill, I started realizing that it's better for chip clearance. I don't want to get these odd-shaped cutoffs caught in the chip auger. And so I started using HSM to just basically whittle away the outside and turn everything into chips. For this thing, it's a one-off. I don't care. I can go fish out the parts by hand. And so I'm going to go back to my old design philosophy of doing the perimeter with a slot, and the slot will start with the Lakeshore Carbide roughing tool, the aluminum shredder. So got the tool in place, and single block. Incorrectal. Oh, work offset 1. So many things to get right, especially when I'm paying attention to making a video. And of course, that's no excuse. I take full credit for all of my mistakes. So, correct work offset. Looking at distance to go, looks sane. Oh, probably shouldn't have programmed that kind of an abrupt feed, but oh well. Looking good. Looking very good. No problem clearing the hold down. Yeah, that entry is too fast, but I don't think it really hurts anything. It just kind of sounds wrong. Running at 90 inches per minute because I'm more confident that I can run faster with this cutter based on experience. And I'm doing it in multiple passes where I probably don't need to. That didn't sound good. Actually didn't sound good at all, but hey, I'm gonna I cut my blank a little bit big, just a fraction oversized, and this actually is ever so slightly the wrong tool path. It's not really wrong, it's not horribly wrong, but it's a tiny bit wrong down here at the bottom, and that's what caused the funny entry points. So I'm going to go ahead and do the finish pass and then fix that up. Yeah, that's looking good. And that, very, very close to a successful part. I do need to take care of that bottomless right there, and I'm not sure if I'll do that on camera or not. Well, what the hell, leave the camera running. I'm going to do it. If it's not that interesting, then I'll edit it out. Okay, get this pig doink. And as I usually do, talk a little about philosophy. That, you know, it's really, when making videos like this, it's really hard to know for sure, what should I show? You know, should I show everything? Should I show my fumbling and stumbling? And yeah, I do. I show the whole thing. I show the fumbling and the stumbling and the mistakes, and you know, that's life in the CNC shop. Sometimes I do get them perfect the first time. Sometimes I don't. Okay, going to be using the 1/2-inch cutter, and I'm going to be checking here, G154, that's correct. Single block. I'm going to be just knocking off that back edge. %, rapid. That looks, boy, it looks like it might be correct, but wow. Hope I don't booger it up. Being very, very careful and conservative on this one. 30 inches per minute with 10 inches per minute Z-axis. Yes. That is correct. The part has been completed, and it is exactly as intended. So, now isn't that something? So, that, let me turn the viewer here. That is the part. And all, let me see, kind of hard to do this on camera, so everything's backward. All of the open areas, the glass is going to go here, inlaid into a piece of wood. This will all be wood inlay, and all you'll actually see of the metal is the rim. So, total success. Whatever problems I had were minor and totally recoverable, and that's it. I'll turn the camera on when I get to the woodworking, which should be kind of interesting. I'm going to be using, I'm not really sure what I'm going to be using. I will probably use the wood router for the wood parts because it has a 25,000 RPM spindle, although I'm tempted to do it on the Haas because, hey, it's a cool machine, but I kind of don't like getting sawdust in my, mixed in with my coolant, although I do have a coolant filter. So anyway, thanks for watching. It's been fun.